In the deep silence of the night, when the world around you finally begins to loosen its grip, the universe reveals something it hides during the day. Far beyond the noise of our cities and the weight of our thoughts, the Milky Way stretches across the sky like a soft river of scattered light. And though those pale, distant stars seem calm and gentle, their glow hides a truth far stranger, far heavier, and far more ancient than anything we can see with our eyes. Because at the very center of our galaxy, tucked behind veils of dust and invisible forces, there is a presence that does not shine, and yet commands the motion of hundreds of billions of stars. A presence that cannot be touched, and yet shapes the very structure of the galaxy you live in. A presence known simply as Sagittarius A. Tonight, in this quiet space between waking and dreaming, we will drift toward that hidden heart of the Milky Way, not with rockets or instruments, but with the soft weightlessness of imagination and understanding. This journey is not about fear. It is not about the violent destruction we often associate with black holes. Instead, it is about something subtler, something more profound. Because Sagittarius A is not merely a monster. It is a foundation, a cosmic anchor, a gravitational conductor orchestrating the slow, elegant dance of our galactic home. So let your breath settle. Allow the tension in your body to melt into the dark, quiet background of the night. Let your thoughts become lighter with every exhale, drifting like stardust on a gentle cosmic breeze. And as you relax, imagine the Milky Way from above. A vast spiral of light, arms curling outward like the slow swirl of milk in still water. Everything turning, orbiting, moving with patient grace. And there, at the very center of this grand rotation, sits the invisible gravitational well that binds it all together. This central region is a crowded and turbulent place, but not in the way we usually imagine chaos. Here, stars do not drift quietly. They race. They sling around the black hole at breathtaking speeds. Some moving so fast that if we could somehow ride alongside them, we would circle the sun in mere minutes. Yet from a distance, even this furious dance appears calm, like fireflies circling a lantern in the dusk. Their orbits trace the invisible outline of something impossibly dense, impossibly compressed, and impossibly powerful. Sagittarius A itself gives off no light, no glow, no heat. It does not reveal its presence willingly. Instead, its existence is betrayed only by the way space curves around it, by the way light bends near its edges, by the way stars behave as if obeying a hidden command. It is like a silent conductor in a cosmic orchestra, guiding every note without ever speaking a word. And yet, even though this black hole is unimaginably massive, 4 million times the mass of our sun, it does not dominate our minds the way it dominates our galaxy. We live so far from it, nearly 26,000 light-years away, that it feels mythical, disconnected, irrelevant to our daily lives. But the truth is that this ancient creature has shaped your entire existence. Without it, the Milky Way would not hold its form. The spiral arms would not curl so elegantly. The stars, including our sun, would drift through space in unpredictable ways. The stability of our galactic home, and by extension, the stability of our planetary home, relies on this quiet monster at the center. There is something strangely comforting about that, something grounding. Because even though Sagittarius A is a black hole, something we often describe as destructive, its role is as much about creation as it is about consumption. It organizes chaos. It stabilizes the galaxy. It provides the gravitational rhythm that allowed our sun to emerge, allowed Earth to form, and allowed life to eventually breathe into existence. Tonight's journey is about stepping gently closer to this paradox. A dark heart that gives shape to light. A monster that anchors everything. A region of space-time where gravity is so strong that the very idea of surface dissolves into meaninglessness. And yet, despite its power, despite its ability to swallow stars whole, Sagittarius A remains quiet. It is not feeding aggressively. It is not tearing apart its surroundings. For the most part, it is dormant, a sleeping giant at the core of a spiral of light. Scientists have spent decades observing this place using radio telescopes, infrared detectors, and the subtle trembling of starlight. And what they saw changed everything. They watched as individual stars traced perfect ellipses around an invisible center. They measured the timing down to fractions of seconds. They observed how space itself seems to dip and curve in ways that only a black hole could explain. And from all this silent data, they uncovered a truth that feels almost mythological. The center of our galaxy is not just heavy, it is mind-bendingly dense, compacted into a region so small that no conventional object could possibly exist there. As we move deeper into this story, you will hear how Sagittarius A bends time, how it distorts light, how it might whisper gravitational waves into the fabric of space-time. You will hear how it may have shaped the early Milky Way, and how it may influence the far future of the galaxy long after our species has faded into dust. You will hear about stars that should have been ripped apart but survived, about gas clouds that approached too closely and were shredded, about flares of energy that burst out from the darkness like cosmic heartbeats. But not yet. Not now. For this moment, simply rest in the knowledge that we are floating toward the most mysterious place in our cosmic neighborhood. Not in fear, not in awe, but in calm curiosity. Take one more slow breath. Let the soft dark of the night wrap around you like a familiar blanket, and let yourself drift deeper toward the quiet, hidden center of our galaxy, toward Sagittarius A, toward the monster and the guardian that holds the Milky Way together. Part 1. The hidden heartbeat of the galaxy. If you close your eyes for a moment, the night around you becomes deeper, quieter, almost weightless. It is in this silence that the story of Sagittarius A truly begins, not with explosions or violence, but with gentle motion, with gravity, with the slow, patient turning of a galaxy that has been spinning for billions of years. Everything starts with movement, and everything, at least within the Milky Way, eventually leads back to the same invisible center. Imagine rising far above our galaxy, as if carried by an unseen current. From that impossible height, the Milky Way unfurls like a vast, glowing spiral painted across the cosmic darkness. Its arms stretch outward in sweeping arcs, filled with billions of stars whose light has traveled through dust and emptiness to reach our eyes. Yet even from this grand perspective, something feels incomplete. The galaxy is turning, gracefully, continuously, but the heart of this motion remains obscured. Hidden behind dense clouds of interstellar dust, invisible to ordinary light, lies the gravitational engine that shapes everything, Sagittarius A. To reach it, we must drift inward, slowly descending through the crowded regions that surround the galactic core. As we move closer, the peaceful structure of the spiral arms begins to change. The space becomes denser here, filled with stars that cluster together like glowing embers in a cosmic hearth. Giant molecular clouds ripple with the birth of new suns. Old stars wander on eccentric paths, tugged and twisted by powerful forces. And then, as we continue inward, the motions accelerate. Paths tighten, Speeds rise. The stars begin to dance, not freely, but in orbits governed by a single, unseen master. These are the S stars, hot and brilliant and young, sweeping around the black hole with astonishing velocity. Some move so fast that they could travel from Earth to the Moon in seconds. Astronomers track them for decades, watching them trace perfect elliptical arcs, each turn whispering an undeniable truth. Only a supermassive black hole could command such motion. Nothing else could fit millions of solar masses into a space smaller than our solar system. Nothing else could anchor an entire galaxy with such silent strength. Yet despite its unimaginable mass, Sagittarius A is quiet. It does not blaze with energy like the monstrous black holes found in distant galaxies. Those that devour stars and unleash jets of radiation stretching across light years. Our galactic center is different. It flickers occasionally, sending out brief, ghostly flares when a cloud of gas wanders too close. But most of the time, it rests, dormant, patient, a sleeping colossus wrapped in darkness. As we drift nearer, the environment grows more chaotic, but also strangely serene. Clouds of gas twist into glowing filaments, heated by the intense radiation of nearby stars. Shock waves ripple through the region, sculpting the interstellar medium into arcs and spirals. Every structure here, from the smallest particle of dust to the largest orbiting star, feels the pull of the black hole. Gravity is not a force in the background. It is the main character, the architect of everything. And yet, even here, so close to a supermassive black hole, there is beauty. A fragile, haunting beauty that emerges from the contrast between immense power and perfect stillness. The stars do not crash. They do not spiral uncontrollably toward oblivion. Instead, they glide through their orbits with astonishing precision, following paths defined by the curvature of space-time itself. Their motion is not chaotic, but harmonious, like notes of a cosmic melody shaped by an unseen hand. This hidden harmony is what scientists find so mesmerizing. Sagittarius A is not a monster in the way our imagination might paint it. It does not tear apart everything around it. For the most part, it barely feeds at all. Instead, it simply exists. A silent gravitational anchor holding together a galaxy that would otherwise drift into shapelessness. Without it, the Milky Way would not have the elegant spiral form we recognize. The stars would wander freely. Our sun, too, might never have formed in the stable environment that allowed life to emerge. As you float in this imagined journey, you begin to sense the truth. The black hole at the center of our galaxy is not a threat. It is a foundation, a quiet heartbeat deep within the cosmic darkness. It sets the rhythm of stellar motion, guiding everything with a force that is felt but never seen. And even though we cannot observe Sagittarius A with our eyes, we have learned to hear its presence through the motion of the stars that surround it. They behave like lanterns in a dark room, circling an object that emits no light. Every wobble, every acceleration, every shift in their trajectory reveals the shape of the invisible. Through them, we have mapped the gravitational contours of a region where space-time dips toward infinity. But we have still only begun to understand this place. The environment around Sagittarius A is filled with mysteries. Strange magnetic fields, unusually energetic particles, filaments that glow for reasons we cannot yet explain. Even the quiet nature of our black hole raises questions. Why is it so calm? Why did it stop feeding? What events shaped its growth billions of years ago? These questions will guide our steps as we move deeper into the story. But for now, simply rest in this moment, suspended above the hidden center, listening to the silent gravitational pulse that has shaped our galaxy since its earliest days. The journey has only begun, and the next step will take us even closer to the edge of the unknown. Part 2. Drifting toward the event horizon. As we continue our descent into the heart of the galaxy, the space around us grows stranger, thicker, and more vibrant with unseen forces. Although this journey is one of imagination and understanding, not physical travel, the sensations feel tangible. The air of the cosmos seems to hum with hidden tension. The stars move differently here. Light behaves differently here. Even time, that steady river that normally flows in a single quiet direction, begins to feel as though it softens around the edges. This is the region where gravity becomes a sculptor, where space-time bends so elegantly that even straight lines curve. And the closer we drift toward Sagittarius A, the more we sense this invisible architecture, a grand, intricate framework woven from the pure weight of the black hole's existence. From afar, a black hole appears simple, a dark sphere surrounded by swirling light. But as we approach the environment around Sagittarius A, the picture becomes far richer. The first thing we notice is the accretion zone, not a traditional disk of blazing gas like the monstrous quasars in distant galaxies, but something gentler. Sagittarius A is not feeding aggressively. It is more like a sleeping creature that occasionally stirs, inhaling only thin wisps of gas from the chaos around it. Yet even these faint breaths are enough to create phenomena beautiful beyond words. Clouds of hot plasma drift in slow spirals, their motions governed by magnetic fields we still struggle to understand. Strands of glowing matter twist like threads in a cosmic loom, illuminated by the radiation of nearby stars. They rise and fall like tides, responding to the shifting gravitational landscape. Some fall inward, disappearing into darkness. Others escape, flung outward by turbulent currents of energy. None of it is chaotic in the human sense. Here, even turbulence has pattern. Even disorder has symmetry. As we drift deeper, the black hole's influence becomes more intimate. A subtle shift occurs in the way distant starlight reaches us. The stars behind the black hole appear distorted, stretched into arcs or rings of light, as though reflected in a rippling lake. This distortion is gravitational lensing, a silent reminder that even light must obey gravity's pull. The space between us and the black hole is no longer empty. It is a lens, a curved window through which the universe is subtly reshaped. The feelings this creates are complex. On one hand, there is an undeniable sense of wonder. Few places in the cosmos reveal the fabric of space-time so clearly, so dramatically. On the other hand, there is a faint sense of unease. Not fear, but humility. We are witnessing a realm in which the familiar rules soften. A realm where distance and direction feel fluid. A realm where the boundary between existence and disappearance is marked by nothing more than a silent, invisible horizon. Yet this journey is not meant to overwhelm. Instead, it asks us to slow down even further, to notice the way gravity changes the rhythm of everything it touches, to sense the subtle stretching of time, to feel, in a metaphorical sense, the whispering pull of the event horizon long before we reach it. The stars closest to Sagittarius A behave unlike any others in the galaxy. Their orbits are compact and intense. They flit around the black hole like sparks encircling a smoldering ember. Some are young, far too young to exist naturally in such a hostile region. Scientists call them paradox stars, because their very presence challenges our understanding. How did they form? Were they born here, in the gravitational furnace? Or did the black hole's tidal forces shepherd older stars into colliding clouds, forging new suns in the midst of chaos? No answer has been proven. The center of the galaxy remains a laboratory filled with mysteries, and each star here is a clue. Yet as we drift among them in this imagined voyage, we notice something else. Despite the intense gravity, despite the violent forces shaping this region, everything feels strangely calm. The stars obey their orbits. The gas moves in patient spirals. Even the black hole itself remains quiet, as though resting beneath a blanket of dust and darkness. This deceptive calm draws us closer. Ahead of us, the light begins to thin. The region grows dimmer, not because there is less illumination, but because the gravity here bends light away from us, pulling photons into paths that curve like ribbons in a gentle wind. Shadows stretch in unusual directions. Colors shift slightly, tinged by the red glow that emerges when light climbs out of a deep gravitational well. Even time, in this imagined approach, seems to slow its pace. The deeper we drift, the longer each moment feels, as though gravity is stretching the seconds themselves. It is here, in this softly distorted region, that we encounter one of the most fascinating structures near Sagittarius A, the so-called photon orbit. This is a boundary where light itself can be trapped in perfect loops, circling the black hole like fireflies moving along invisible rails. Photons that step too far inward spiral inevitably toward the event horizon. Those that remain just outside continue their eternal loop, caught between escape and surrender. We do not cross this boundary. Instead, we pause at its edge, observing the way space behaves, the bending of trajectories, the shimmering arcs of twisted light, the faint fluctuations in brightness that sweep across the region like ripples on a dark pond. These flickers are real. Astronomers have detected them as brief flares from Sagittarius A, likely caused by small pockets of matter heating up as they momentarily spiral near the photon orbit before slipping away or falling inward. From here, we can almost sense the presence of the event horizon itself, not as a visible edge, but as a silence, a subtle absence, a place where all paths curve inward, a place where time and space begin to funnel toward a single, inescapable destination. But our journey is not one of crossing. It is one of understanding. We remain outside the horizon, drifting safely through the distorted region, observing, listening, absorbing the strange beauty of this gravitational cathedral. Eventually, we turn gently away from the photon orbit. The journey will continue, but not yet into the darkness beyond the horizon. That part of the story belongs to another chapter. For now, we settle into the quiet space just outside the boundary of no return, letting the silence and the subtle warping of starlight wash over us. The heart of the galaxy beats softly here, and our path toward deeper understanding continues. Part 3. The Stars That Shouldn't Exist. As we linger in the softly warped space just outside the photon orbit of Sagittarius A, a new layer of mystery begins to reveal itself, one that has puzzled astronomers for decades. It is here, in this chaotic gravitational environment, that we encounter something astonishing. Stars that, by all conventional understanding, should not exist. And yet, they are here, bright, young, vibrant, moving with impossible speed through a place where stars should have been torn apart long before they ever had the chance to live. These are the S stars, the strange, paradoxical children of the galactic center. To understand why they are so extraordinary, we must step back, gently, without losing the meditative state of our cosmic drift, and recall what gravity does in such regions. Near a supermassive black hole, tidal forces are intense. They stretch and compress matter in violent ways. Gas clouds cannot remain intact long enough to collapse into stars. Even if one tried, the sheer forces near the event horizon would rip it apart like mist in a storm. And yet, the S-stars exist. Their orbits are tight ellipses around Sagittarius A, some bringing them incredibly close to the black hole. They swoop inward, swing around at breathtaking speeds, and soar back out again, tracing paths that look like calligraphy written across space-time. The closer they pass to the black hole, the more dramatically their paths curve. And with each orbit, they provide a new clue, another whisper from the darkness, revealing the nature of the invisible monster at the center. But the question remains, where did they come from? How did stars like these form and survive in such an extreme environment? Scientists have proposed several possibilities, each more intriguing than the last. One idea suggests that these stars were born farther out in the galaxy, in calmer, more stable regions where star formation is common. Then, through interactions with giant molecular clouds or passing clusters, they were gradually drawn inward. Over millions of years, their orbits decayed until they were captured by the black hole's gravitational field. This scenario is peaceful, almost elegant, but it struggles to explain the youth of the stars. They are far too young to have had enough time to migrate from faraway nurseries to the galactic center. Another possibility is more dramatic. It proposes that these stars are the survivors of violent collisions between stellar clusters near the center. Imagine massive groups of stars spiraling inward, pulled ever closer to the supermassive black hole. As their paths tighten, the clusters begin to merge. In the chaos of these mergers, some stars are flung outward, while others are slingshotted inward. A few become trapped in the black hole's gravitational embrace, forming the fast-moving S-star population we see today. This model explains their location, but not their youth. A third hypothesis is the most surprising of all. It suggests that star formation may occur in brief, intense bursts, even within the harsh gravitational environment of Sagittarius A. If a sufficiently massive cloud of gas falls inward, and if it remains dense enough for long enough, it may collapse under its own gravity before the tidal forces of the black hole tear it apart. This would create new stars, young, hot, luminous stars, right in the shadow of the event horizon. It is a beautiful idea, a poetic one. Stars born in the darkness, surviving where nothing should survive. And yet, even this explanation feels incomplete. The environment near Sagittarius A is not only gravitationally extreme, it is chaotic, turbulent, and filled with high-energy radiation. Everything here should conspire against the birth of stars. And so, despite decades of study, the origin of the S-stars remains an open cosmic riddle. As we float in this imagined space, watching the S-stars carve luminous arcs through the warped geometry, a strange kind of calm settles over us. These stars are not accidental. Their presence is not random. They are signposts, cosmic markers that point toward a deeper understanding of the black hole at the center of our galaxy. One star in particular stands out, S2. It is the most famous of the S-stars. Astronomers have tracked it for more than 25 years. S2 completes an orbit every 16 years, an incredibly short period for a star orbiting something so massive. During its closest approach, it plunges deep into the gravitational well of Sagittarius A, traveling at thousands of kilometers per second. At that moment, its motion becomes a direct test of Einstein's general theory of relativity. Light from the star stretches into longer wavelengths. Time dilates, space curves, and all of it unfolds precisely as Einstein predicted. Observing S2 was one of the clearest signs that Sagittarius A is, in fact, a supermassive black hole, But beyond its scientific importance, S2 is mesmerizing to watch. In our imagined vision, we see it trace its long, stretched orbit with graceful determination. Each pass near the black hole is like a cosmic heartbeat, a reminder that even in the most extreme environments, the universe can maintain patterns, rhythms, and quiet forms of order. Around it, other S-stars follow their own paths. Some orbit slowly and widely. Others plunge inward with dizzying speed. Together, they form a swarm of motion, a stellar ballet choreographed by the invisible hand of gravity. And yet, as beautiful as this dance is, it also carries a subtle tension. Any of these stars could, under the right circumstances, be pushed too close to the event horizon. A slight gravitational nudge, a passing interaction with another star, or even the buildup of tiny perturbations over millions of years could send one spiraling inward. What happens then is a question we will explore in later chapters. But for now, the image is enough. A star approaching the point of no return, its light stretching, its orbit tightening, until finally it is swallowed by darkness. For now, though, the S-stars endure. They shine. They orbit. They defy the odds. And as we drift among them in this quiet, meditative journey, we begin to sense the deeper theme emerging. The idea that the universe is not simply a place of destruction and danger, but also a place of resilience, a place where beauty finds ways to exist even in the harshest environments, a place where stars can thrive beside monsters. The paradox of the S-stars lingers with us as we gently drift away from their orbits. Their existence is a question with no final answer, a whisper from the galactic center that invites us to listen more closely. And in the next part of our journey, we will follow that whisper deeper still, toward the swirling, turbulent structures that feed the black hole, and toward the silent boundary where light itself begins to falter. Part 4. The tidal engines of creation and destruction. The deeper we drift into the central region of the Milky Way, the more the environment begins to shift. Not in sudden, dramatic ways, but subtly, like the dimming of a lantern or the soft change in pressure before a distant storm. Here, gravity is not simply a force. It is a landscape. It molds everything. Gas, dust, stars, even the passage of time itself. And if Part 3 introduced us to the stars that should not exist, Part 4 reveals the forces that allow such paradoxes to happen, and the darker forces that threaten to tear them apart. These forces are known as tidal forces, the stretching, squeezing, twisting effects of gravity when it changes rapidly over small distances. Around Earth, tides move the oceans. Around Sagittarius A, tides become powerful enough to unmake the very structures of matter. To understand this tidal environment, imagine 2 points in space, one slightly closer to the black hole, one slightly farther. The closer point is pulled harder. The farther point is pulled less. This difference in gravitational pull creates a stretching effect, like the cosmic equivalent of taffy being pulled in opposite directions. The closer an object drifts, the more extreme this stretching becomes. And yet, in our imagined journey, the sensation is not violent. It feels more like pressure, a gentle tightening of the space around us, a quiet reminder that we are approaching a region where the rules of the universe warp into shapes rarely seen elsewhere. We move through a cloud of gas that has wandered too close to the gravitational well. Its edges are already beginning to fray. Portions of it stretch into long filaments, other parts curl inward, drawn into spiral arcs that twist like cosmic threads through the darkness. At first glance, this seems chaotic. But as we drift deeper, patterns emerge. The gas forms loops and crescents. Some filaments fall inward, fading into darkness. Others snap outward into long, thin streams, flung away by the turbulent gravitational currents. In this region, creation and destruction happen side by side. Some of these tidal interactions compress clouds of gas, making them denser, hotter, more turbulent. Under the right conditions, these compressed regions can ignite new stars, an unexpected burst of creation in the shadow of the black hole. Other clouds, less fortunate, are stretched so violently that their internal structure collapses. They unravel into long strands of ionized material that arc across the sky like cosmic lightning before dissolving into the accretion flow. It is here that we witness the beginning of one of the most spectacular phenomena associated with Sagittarius A: tidal disruption events. A tidal disruption event occurs when a star wanders too close to the black hole. The gravitational tug on the near side of the star becomes dramatically stronger than the pull on the far side. At first, the star stretches. Then it elongates. Then, if it crosses the critical threshold, the star is torn apart in a brilliant, catastrophic display of cosmic violence. Half of the star's material is flung outward into space, forming glowing streams of gas that radiate in all directions. The other half circles inward, spiraling toward the event horizon. As the gas falls, it heats to millions of degrees, creating a flare so bright that it can outshine the entire galaxy for a moment. These flares, though brief, are among the most luminous events the universe can produce. And they are the black hole's rare moments of feeding, its occasional awakenings from long periods of rest. But here is the strange truth. Sagittarius A does not perform these dramatic displays often. In fact, it is unusually calm for a supermassive black hole. The tidal forces around it are powerful enough to destroy stars, yet stars continue to orbit safely. Gas clouds wander through the region without always being consumed. Even the violent flares it produces are surprisingly mild compared to those seen in distant galaxies. Scientists believe this calmness may be temporary, an interlude in a long series of cosmic cycles. Some evidence suggests that a few centuries ago, Sagittarius A was far more active. Ancient X-ray reflections from nearby clouds hint at past flares, bright enough to illuminate entire nebulae. And in the far future, perhaps millions of years from now, it may awaken again, powered by new material drifting inward. But for now, it sleeps. As we continue our slow descent through this tidal environment, our path takes us past one of the most extraordinary regions near the black hole, the circumnuclear disk. This ring of dense gas encircles the black hole like a distant halo, thick, turbulent, and full of potential. Its filaments churn and collide, its currents twist around themselves. And deep within its mass, gravity pushes and pulls, creating pockets of intense compression. Some of these pockets may collapse into stars, forming new clusters that will eventually join the dance of the galactic center. Others may migrate inward, feeding the black hole in slow, delicate streams that produce faint flares detectable from Earth. This disk is chaotic, yet stable, violent, yet enduring. It is a place where the contradictory forces of the galaxy blend together, where creation, destruction, turbulence, and order coexist in a delicate, ever-shifting equilibrium. As we drift along its glowing edges, we can feel the rising pressure of the black hole's tidal forces. Time stretches lightly. Light bends softly. Space feels less rigid, as though the very fabric of the cosmos is gently moving beneath us. The deeper we go, the more apparent it becomes that nothing here is static. Everything is fluid, dynamic, alive. We pass through pockets of warm dust that glow in infrared hues. We glide by arcs of ionized gas sculpted by magnetic fields threading through the region like invisible currents. These magnetic fields are twisted, warped, stretched into long filaments that span light years, structures scientists still struggle to fully explain. They seem to drift through the region like illuminated threads, glowing faintly in the dark. And as we drift among them, we sense something profound. The tidal environment around Sagittarius A is not just destructive. It is also deeply creative. It shapes stars. It sculpts gas. It forms structures that cannot exist anywhere else in the galaxy. The quiet paradox of the galactic center begins to come into focus. The black hole destroys, but it also preserves. It tears apart, but it also creates. It silences, but it also shapes the rhythms of the stars. And as we continue toward the next chapter of our journey, we move closer to the event horizon itself, the boundary where all paths curve inward and where the mysteries of gravity deepen into the unknown. Part 5. The Quiet Giant. Why Sagittarius A sleeps as we drift deeper into the galactic core. Leaving behind the tidal engines that stretch, compress, and sculpt the material around the black hole, we enter a quieter, more enigmatic region, one defined not by violence, but by absence. A stillness hangs here, delicate and strange. It is the calm that surrounds a force of unimaginable power. It is the hush before a breath, the pause between heartbeats. This is the place where we begin to understand one of the most puzzling mysteries of Sagittarius A. Why is our supermassive black hole so quiet? Compared to the monstrous black holes at the centers of other galaxies, Sagittarius A is faint, astonishingly faint. Many galaxies boast quasars, black holes that blaze with brilliance, devouring matter and unleashing energy bright enough to outshine trillions of stars. Their accretion disks glow like cosmic furnaces. Their jets pierce through space like spears of plasma. Sagittarius A is nothing like them. It sits at the center of the Milky Way, like a sleeping colossus, massive, ancient, and almost entirely silent. But silence does not mean inactivity, and stillness does not mean simplicity. To understand why Sagittarius A sleeps, we must look closely at what surrounds it and what doesn't. The first reason is the lack of fuel. A black hole can only feast on what falls into its gravitational grasp. If gas, dust, or stars do not cross close enough to be drawn inward, the black hole remains hungry. The central region of the Milky Way contains vast clouds of gas, but much of this material is hot, energetic, and turbulent. Instead of collapsing inward, it swirls chaotically, resisting the pull of gravity. Much of it is blown outward by stellar winds from massive stars. Some of it orbits in stable, high-speed paths. Only a small fraction ever drifts close enough to be consumed. And when material does reach Sagittarius A, it often arrives in tiny amounts, thin filaments rather than thick torrents. These faint streams generate only weak flares, short-lived and subtle. From Earth, these flares appear as soft flickers in X-ray or infrared wavelengths, gentle sparks from the sleeping giant. But fuel alone does not fully explain the silence. A second reason lies in the black hole's magnetic environment. Sagittarius A is surrounded by tangled magnetic fields that act like a cosmic barricade. These fields twist and coil through space, shaping the motion of gas and plasma. If the magnetic configuration is just right, it can prevent material from spiraling inward. Instead of falling freely, the gas becomes trapped in chaotic eddies, like leaves caught in circular winds. Only when these fields shift or break does material slip through, creating brief flares that last minutes or hours. This magnetic bottleneck may be one of the key reasons why Sagittarius A remain so dim? The black hole is not starved. It is fenced in, prevented from feeding efficiently. A third reason lies in the geometry of space-time itself, near the event horizon. The region is dominated by a phenomenon known as radiatively inefficient accretion. In simple terms, matter falling toward Sagittarius A does not glow as brightly as it should. Instead of radiating energy and creating dazzling flares, the heated gas becomes trapped in the swirling flow and plunges inward before it can radiate much light. The energy that would normally escape is swallowed. This means that even when Sagittarius A feeds, it does so quietly, devouring material without dramatic displays of radiation. But perhaps the most fascinating explanation is the historical one. There is growing evidence that Sagittarius A was once far more active, perhaps even luminous enough to rival a small quasar. Observations of nearby nebulae, especially the mysterious Fermi bubbles and the X-ray reflections seen in clouds like SGR-B2, suggest that just a few centuries ago, the black hole may have unleashed a powerful flare. Some estimates suggest it could have been millions of times brighter than it is today. If this is true, then what we are witnessing now is merely a pause, a quiet phase in a long cycle of activity. Black holes evolve, their feeding habits shift, their surroundings change. Sagittarius A may be resting, recharging, waiting for the next large reservoir of material to drift inward. As we float through this tranquil region, a strange sensation emerges. The quietness feels intentional, like the breath between cycles. The stars around us move softly. The gas flows gently. The magnetic filaments shimmer faintly. Everything seems suspended in a delicate balance, as though the galaxy is holding still around its slumbering heart. But this calm is deceptive. At any moment, next year, next century, or 10,000 years from now, a cloud of gas could plunge inward. A passing star could be disrupted. A dense cluster could spiral closer. And in that moment, the quiet giant would awaken. We imagine, for a moment, what such an awakening might look like. The gas would heat to millions of degrees, glowing in X-rays. Light would bend dramatically around the black hole's silhouette, creating a luminous crescent. Jets could erupt along magnetic field lines, shooting plasma across light years. The central region of the Milky Way would flare with a brilliance not seen in human history. Earth itself might see the glow, a faint, ghostly illumination rising from the direction of Sagittarius. But that future is uncertain. It may never come, or it may already be beginning in ways too subtle for us to see. For now, though, the giant sleeps, and the galaxy sleeps with it, calm and balanced around a center that exudes both power and stillness. As we drift away from this quiet region, preparing to explore the warped frontier near the event horizon, we carry with us a new understanding. Sagittarius A is not defined by its violence, but by its restraint. A black hole that sleeps for centuries, perhaps millennia, holding its power in silence. In the next chapter, we will arrive at the brink of the ultimate boundary, the event horizon itself, where space and time curve toward the ultimate mystery, and where the calm quiet of the galactic center gives way to the deepest silence in the universe. Part 6. At the Edge of No Return. As our journey carries us closer to the ultimate frontier surrounding Sagittarius A, the atmosphere of the galactic center begins to change once more. The clouds of gas grow thinner. The magnetic filaments drift farther apart. Even the bright, chaotic swirl of nearby stars grows dimmer as we approach a boundary unlike any other in the universe. A boundary that cannot be touched, cannot be crossed, and cannot be seen, yet governs everything inside it with absolute authority. This is the threshold of the event horizon. Even in this imagined descent, where we float through a cosmic meditation rather than a physical voyage, a sense of gravity, literal and metaphorical, settles over us. Time feels slower. The air of our imagination feels thicker. The silence deepens into something profound, something absolute. We are approaching the place where escape becomes impossible. But to appreciate the meaning of this boundary, we must first understand what it is not. The event horizon is not a surface. It is not a wall. It is not a physical shell separating one region of space from another. Instead, it is a mathematical boundary, a tipping point in space-time. A place where all paths curve inward, where even light, the fastest thing in the universe, loses the ability to flee. From a distance, the event horizon appears calm, pristine, perfectly smooth, a serene black sphere carved out of space-time. But examine it closely, through the eyes of theory, through the predictions of Einstein's equations, and a hidden complexity appears. The first thing we notice as we drift toward it is the gravitational redshift. Light from the stars behind us grows slightly softer, its wavelength stretching as it climbs out of the deep gravitational well. Colors shift subtly. Blues fade into whites. Whites slip into warmer tones. And as we drift even closer, these colors fade further still, transforming into wavelengths that the human eye cannot perceive. The universe does not go dark, but it becomes invisible in familiar ways. This shift is not dramatic. It happens slowly, like dusk settling over a quiet landscape. But its meaning is profound. Time itself is changing. In our imagined journey, the seconds begin to lengthen, not in a frightening way, but in a soft, meditative stretching. Each moment becomes slightly fuller, slightly deeper. This is not an illusion. Near a black hole, time genuinely slows relative to distant observers. The clock carried toward the event horizon ticks more slowly. A heartbeat lasts longer. A single breath spans a fraction more eternity. To an observer far away, our journey seems to slow. We would appear to drift increasingly slowly as we approach the horizon. Our motion would freeze entirely the instant we reached it, locked forever in a moment of descent. But to us, inside this imagined experience, time flows normally. The difference is simply perspective, one of the most beautiful and mysterious effects predicted by general relativity. As we drift even closer, we begin to feel the curvature of space itself, not as a physical sensation, but as a change in how distances behave. Directions no longer feel perfectly straight. Paths that should diverge instead bend inward. Space becomes a funnel, gently guiding everything toward the unseen center. The black hole's silhouette grows more defined, not as a physical surface, but as a region where no light escapes. Around it, a faint halo glows. The photon ring, created by light that orbits the black hole multiple times before escaping. This ring is thin, delicate, and mesmerizing, like a perfect circle of fire drawn around the mouth of eternity. We pause here, suspended above the event horizon, observing this shimmering boundary. The photon ring is not a permanent structure. It flickers, shifts, and warps as light dances along unstable trajectories. Yet, from afar, it appears almost timeless. This is the closest we will come. To cross the event horizon, even in imagination, would be to leave the realm of the observable. It would take us into a place where understanding dissolves, where space and time twist in ways no human mind can fully grasp. Our journey is not meant to enter the unknown, but to explore the edge of it, to stand at the brink and look into the deepest silence the universe can offer. So we remain here, hovering at a respectful distance. From this vantage point, the black hole is no longer simply an object. It feels like a presence. Silent, massive, unyielding. It does not move, yet it commands motion. It does not radiate, yet it shapes light. It does not speak, yet it dictates the flow of time. We observe the last moments of matter falling inward. Small clumps of gas spiral around the photon orbit, heating to millions of degrees. They flare briefly, sending flashes of X-ray light across space. These flares unravel quickly, fading into the darkness below. Swallowed by the horizon, we see the distorted reflections of distant stars stretched into arcs around the black hole's limb. Their light bends, wraps, and collects into strange, shimmering patterns. Some paths loop entirely around the black hole before reaching us. Others skirt the edge of the photon ring. Every photon here is a traveler on a curved road. And through it all, there is an overwhelming stillness. This close to the event horizon, all energies seem muted. All motion appears slowed. The chaotic swirl of the galactic center feels distant, softened by gravity's embrace. Even the tidal forces we felt earlier have quieted, smoothed by the black hole's perfectly symmetrical geometry. There is a profound paradox here. The region of greatest gravitational power feels the most serene. Perhaps it is this serenity that makes black holes so captivating. They are the quietest places in the cosmos, yet also the most final. They erase information, collapse structure, and end the histories of stars. And yet, they are also the engines of galaxy formation, the anchors that give shape to cosmic evolution. They are destruction and structure woven into one. As we linger at the brink, a realization unfolds gently. The event horizon is not simply a boundary. It is a horizon in the truest sense, a limit of knowledge. Beyond it lies a realm where our understanding breaks down. The laws of physics as we know them dissolve. The inside becomes inaccessible not only to light, but to meaning. And so we honor this boundary. We do not cross it. We drift along its edge, absorbing its presence, its silence, its gravity. The journey is far from over. In the next chapter, we will turn outward once more, exploring how Sagittarius A influences not just the immediate region around it, but the entire Milky Way, shaping stars, sculpting gas, and guiding the long-term evolution of our galactic home. Part 7, The Galactic Architect. How Sagittarius A shapes the Milky Way. As we drift away from the quiet brink of the event horizon, the immense weight of Sagittarius A remains behind us like a shadow carved into space-time. Yet even as we move outward, the influence of the black hole does not fade. Instead, it expands in scope. It stretches far beyond the immediate surroundings of the galactic center, reaching outward through tens of thousands of light years. It extends through the spiral arms, through the clouds of gas, through clusters of stars, including the region where our own sun was born. In this chapter, we explore one of the most profound truths of the Milky Way. Sagittarius A is not merely a gravitational monster. It is the architect of our galaxy's structure. Its presence shapes everything, from the rotation of the spiral arms to the density of star-forming regions. And in its quiet, unseen way, it has influenced the very existence of Earth. To understand this influence, we need to imagine the entire Milky Way from above once more. Picture its luminous arms curling outward in elegant spirals. These spirals are not static patterns. They are density waves, regions where stars and gas experience periodic compression as they move through the galaxy. The rhythm of these waves is partly determined by the mass at the center, the gravitational anchor around which everything rotates. Without Sagittarius AB, the Milky Way would not spin the way it does. The spiral arms might unwind. The disk might wobble. Over billions of years, the galaxy could become distorted, losing the orderly pattern that has shaped star formation for ages. Sagittarius A stabilizes the entire structure. Its gravitational influence sets the pace of the rotation curve, the way stars move at different distances from the center. In a galaxy with no central mass, stars farther out would move more slowly. The outer disk would lag. But in the Milky Way, the presence of Sagittarius A and the halo of dark matter around the galaxy creates a different pattern. Stars maintain higher orbital speeds even at great distances. This stable rotation helps maintain the structure of the spiral arms, guiding clouds of gas into regions where they can collapse and form new stars. We drift now along one of these spiral arms. The landscape changes dramatically from the dense environment of the galactic center. Here, giant molecular clouds stretch across dozens of light years. Nebulae glow with the faint luminescence of ionized gas. Star clusters shimmer like scattered jewels against the dark backdrop of space. And all of it, every star, every cloud, every cluster, is participating in the immense rotation of the Milky Way around its central anchor. Our own Sun is part of this motion. It completes a full orbit around Sagittarius A once every 250 million years, a journey sometimes called the galactic year. Since its formation, the Sun has completed about 20 of these cosmic revolutions. Each orbit carries it through different regions of the galaxy, through changing patterns of radiation, dust, and stellar density. These shifts may even have influenced the climate of Earth, the evolution of life, and the long-term patterns of extinction and renewal. All of this, every shift, every cycle, every evolutionary pressure, unfolded under the influence of Sagittarius A. And yet, the black hole's impact extends even deeper. The mass at the galactic center helps drive the flow of gas through the Milky Way's disk. Over millions of years, gas slowly migrates inward, funneled by gravitational interactions and collisions. Some of this material fuels star formation. Some becomes part of the central bulge. And some journeys all the way to Sagittarius A, feeding the black hole in faint trickles that produce the gentle flares we observe today. This inward drift of gas also shapes the life cycle of the galaxy. Without it, star formation would slow dramatically. Over time, the galaxy would become cold, inert, and dark. But the presence of Sagittarius A helps sustain the slow but steady flow of gas that keeps the Milky Way alive. And in the most distant past, its influence may have been even stronger. There is evidence that, billions of years ago, Sagittarius A was far more active. It may have produced powerful jets, streams of plasma that shot out perpendicular to the galactic disk. These jets could have stirred the gas in the central region, triggering intense periods of star formation. They may have carved out vast cavities in the halo, leaving behind structures like the mysterious Fermi bubbles, giant lobes of high-energy particles extending tens of thousands of light-years above and below the galactic plane. If Sagittarius A did shape these enormous features, then it influenced not only the center of the galaxy, but also its outer halo, affecting cosmic rays, magnetic fields, and the large-scale environment through which the Milky Way moves, and perhaps, in subtle ways, shaping the conditions that allowed our solar system to emerge where and when it did. As we drift farther outward, following the path of the Sun's orbit, we begin to appreciate the interconnectedness of the galaxy. Every region, every cloud, every cluster is part of a grand, slow-motion choreography. And at its heart lies the invisible conductor, silent, unmoving, yet essential to the rhythm of everything. Sagittarius A does not simply sit at the center, it defines the center. It does not simply influence the galaxy, it organizes it. It does not simply consume, it shapes. We pause once more, letting this realization settle into the quiet spaces of our imagination. Even at this distance, thousands of light years from the event horizon, the presence of the black hole is felt. It guides the orbits of stars. It contributes to the stability of the galactic disk. It shapes the patterns of gas flow. It influences the long-term cycles of star formation. It is, in a very real way, the heart of the Milky Way. As we continue drifting outward through the spiral arms, the galaxy reveals itself not as a chaotic collection of stars, but as a living structure, one held together by a balance of forces, a harmony between gravity, motion, and time. In the next chapter, we will explore one of the most extraordinary consequences of this harmony: the way black holes interact with their surroundings over cosmic timescales, and how Sagittarius A's might evolve in the future, awakening, resting, and shaping the fate of the Milky Way across billions of years. Part 8. The Awakening Cycles of a Galactic Giant. As we continue drifting through the luminous spiral arms and back toward the central regions of the Milky Way, a question begins to echo through our quiet cosmic journey. Softly at first, like a distant vibration, then with growing clarity, will Sagittarius A remain quiet forever? In the vast timescales of the universe, black holes do not behave like static objects. They evolve. They shift from silence to activity and back again. They flare, sleep, and awaken in long, slow cycles. Their influence on the galaxy is not constant, but modulated by the ebb and flow of cosmic material drifting inward. To understand the future of Sagittarius A, we must look into its past, and into the delicate balance that governs its feeding cycles. For centuries, perhaps millennia, our black hole has been in a state of deep slumber. It emits barely a whisper of radiation, feasting only on thin streams of gas. But the calm is deceptive. Evidence scattered across the Milky Way reveals that Sagittarius A is capable of moments of extraordinary power. We begin with the most dramatic clue, one written across the sky itself. Far above and below the galactic disk stretch two enormous, balloon-like structures of high-energy particles known as the Fermi bubbles. They extend nearly 50,000 light-years into the galactic halo. Their edges glow faintly in gamma rays, X-rays, and microwaves. Their shape is clean, symmetric, and unmistakably tied to the center of the galaxy. These bubbles are believed to be footprints, vast scars, left by a past outburst from Sagittarius A. Perhaps millions of years ago, the black hole awoke from its slumber and released tremendous jets of energy, carving these enormous cavities into the halo of the Milky Way. Such outbursts are common among active galactic nuclei, quasars, and supermassive black holes in other galaxies. That our own black hole once exhibited similar behavior suggests that the Milky Way too had an active phase. And then, just as suddenly, it quieted again. Closer to the center, more clues shimmer in the clouds of gas. One, in particular, glows strangely bright in X-rays. B2A, a massive molecular cloud. This brightness is not its own. Instead, it is a reflection of a powerful flare that erupted from Sagittarius A roughly 400 years ago. In cosmic terms, that is yesterday. The flare may have been tens of thousands of times more luminous than anything Sagittarius A emits today. Powerful enough that, had humanity already invented telescopes at the time, our ancestors might have witnessed a faint glow rising from the galactic core. Even more recently, within the past few decades, astronomers have observed brief, sharp bursts of infrared and X-ray light from the black hole. These flares last only minutes or hours, triggered perhaps by small clumps of gas spiraling inward before disappearing forever. Though tiny compared to ancient eruptions, they are reminders that Sagittarius A is not inert. It is responsive, reactive, alive in its own mysterious way. The past paints a clear picture. Sagittarius A has awakened before. It will awaken again. To understand how, we drift inward through regions where gas clouds wander on erratic orbits. Many of these clouds are tenuous. They graze the gravitational influence of the black hole but escape, stretched slightly, disturbed but intact. Yet others spiral inward, losing angular momentum, slowly drifting closer to the center. One such cloud, known as G2, approached Sagittarius A in 2014. Astronomers predicted a dramatic feeding event as it neared the black hole. Yet shockingly, little happened. The cloud survived, stretching into a long filament and swinging away again. This unexpected twist revealed that the gas near the black hole behaves in ways we still do not fully understand. Magnetic fields, shock waves, and turbulent flows interact in complex, delicate patterns that determine whether material feeds the black hole or merely brushes past it. Now imagine the opposite scenario. A dense cloud, far more massive than G2, drifting inward. If such a cloud approached the black hole, tidal forces would strip it apart. The material would swirl inward, forming a temporary accretion disk. The gas would compress, heat to millions of degrees, and radiate intensely. Jets could erupt, powered by the twisting magnetic fields near the event horizon. The quiet center of the Milky Way would flare, illuminating the surrounding nebulae. We let this imagined awakening play out in our mind. A faint glow at first, then a rising brilliance, a luminous crescendo, a storm of radiation that ripples through the surrounding gas. From afar, Earth would not be harmed. The distance is too great. But our telescopes would detect a sudden brightening, a new light in the heart of the Milky Way. For the first time in human history, we would witness our galaxy's supermassive black hole awakening in real time. But even this is only one possible future. Another path lies in the slow dance of stars. As we drift through the central region, we notice how densely packed the stars are here. Millions crammed into a volume far smaller than the space around our solar system. Over billions of years, gravitational interactions between stars will cause some of them to lose momentum and spiral slowly inward. One of these stars may one day wander too close, triggering a tidal disruption event. A brilliant flare would erupt, bright enough to be visible across the galaxy. One star, one moment, one awakening. Sagittarius A might also grow gradually, through the steady accretion of gas drifting inward over millions of years. The black hole could brighten slowly, becoming an active nucleus once again. Quiet at first, then increasingly luminous, shaping the core of the galaxy the way it did in ancient epochs. The future is not fixed. Black holes evolve based on what the galaxy gives them. What we know is this: Sagittarius A is not simply sleeping. It is waiting for the next cloud, the next collision, the next star, the next chapter in its long, cosmically patient existence. As we drift outward once more, leaving behind the hints of future awakenings, a new understanding settles over our thoughts. The Milky Way is not static. Its center is not dead. Its heart is not silent. It beats slowly, across millions of years. A rhythm too deep for human timescales, but fundamental to the life of the galaxy. In the next chapter, we will explore the mysterious environment that surrounds Sagittarius A on a larger scale. How entire clusters, filaments, and magnetic structures interact with its gravity and shape the cosmic ecosystem of the galactic core. Part 9. The Cosmic Ecosystem Around Sagittarius A. As we drift once more into the glowing heart of the Milky Way, a deeper understanding begins to form. Slowly, gently, like a nebula gathering into shape. The center of our galaxy is not a single object. It is not merely Sagittarius A's, nor the dense cloud of stars that surround it. It is an ecosystem, a self-sustaining, interwoven environment where gravity, magnetism, radiation, dust, gas, and time all interact in a delicate, ever-evolving harmony. To understand the true role of Sagittarius A, we must explore this ecosystem, not as isolated components, but as a living cosmic web. The environment surrounding the black hole is both extreme and unexpectedly orderly. From afar, it appears chaotic. Stars racing at breakneck speeds, gas clouds colliding, magnetic fields twisting into enormous filaments. But from within our meditative drift, the chaos resolves into pattern. Motion becomes rhythm. Turbulence becomes structure. We begin with the stars. The central parsec, just a few light years across, is packed with more than 1 million stars. Some are ancient red giants. Others are young, massive, blue-white suns. Many orbit the black hole in tight ellipses. Their combined radiation floods the region with ultraviolet light, heating the surrounding gas into glowing arcs. Their stellar winds collide, creating shock waves that ripple like invisible waves across the interstellar sea. These winds shape the environment dramatically. They carve cavities in the gas. They compress clouds into dense pockets. They disrupt magnetic fields, twisting them into knots and filaments that glow in radio wavelengths. And all of it happens under the gravitational rule of Sagittarius A, which organizes the motions of the stars like a conductor guiding an orchestra. We drift next into the swirling gas clouds that permeate the region. Far from empty, the central zone is filled with dense molecular structures, some stretching dozens of light years. These clouds are pulled, twisted, and shaped by the black hole's gravity. Some drift inward. Others are launched outward by stellar winds or collisions. The gas forms vast spirals, cosmic streamers that resemble rivers of smoke winding toward the black hole. These spirals feed the circumnuclear disk, a torus of gas and dust that encircles Sagittarius A like a wide, turbulent ring. Within the disk, shock waves and gravitational tides sculpt the material into filaments. Some of these filaments collapse into stars. Others break apart. Some fall inward, forming weak accretion flows. Others escape altogether. The circumnuclear disk is one of the strangest and most beautiful structures in the galactic core. It glows faintly in infrared light, its temperature and density changing constantly. Despite its chaotic appearance, its gravitational stability is remarkable. Maintained by the combined influence of the black hole, the surrounding stars, and the magnetic fields that thread through it like invisible vines. These magnetic fields are the next element in our cosmic ecosystem. They stretch across the region in long, vertical filaments. Structures so tall, they extend far above the galactic plane. These filaments glow faintly in radio light, tracing the paths of energetic particles spiraling along magnetic lines. Their origin remains a mystery. Some believe they are anchored to the spin of the black hole. Others suggest they emerge from turbulent dynamos within the circumnuclear disk. A few theories link them to the aftermath of ancient jets that once erupted from Sagittarius A. Whatever their origin, these magnetic filaments shape the region profoundly. They confine and guide energetic particles. They influence how gas collapses into stars. They help determine whether matter drifts inward toward the black hole or flows outward into the galaxy. In many ways, they act like the skeletal structure of the central ecosystem. an invisible scaffolding that holds the region together. As we drift deeper into this magnetic forest, we encounter the Arches cluster and the Quintuplet cluster, two extraordinary groups of massive stars orbiting not far from the black hole. These clusters are laboratories of extreme physics. They contain some of the hottest, most luminous stars in the galaxy. Their radiation ionizes nearby gas clouds. Their winds collide with ferocious intensity. Their massive supernovae seed the region with heavy elements. These clusters, like everything else near Sagittarius A, exist because the environment allows them to. Gravity compresses gas into tight pockets. Shock waves ignite new star formation. And the black hole's immense mass stabilizes the dynamics of the central region over millions of years. But this ecosystem is not static. It evolves, it breathes. We drift now toward the edges of the galactic core, where the dense environment fades into the broader disk of the Milky Way. Here, the influence of Sagittarius A is still present, but softer, felt through the gentle curvature of orbits, through the density waves that guide the spiral arms, through the pathways of radiation and magnetic structure that extend outward like faint ripples. What becomes clear is that the galactic center is not defined by chaos or destruction. It is defined by balance, a balance between light and shadow, between gravity and motion, between creation and collapse. Sagittarius A sits at the heart of this balance, not as a tyrant, but as an anchor. A quiet, massive core that holds the galaxy together while allowing its structures to evolve. In this quiet moment of reflection, we begin to understand the deeper nature of the black hole. It is neither monster nor myth, neither devourer nor destroyer. It is a regulator, a stabilizer, a gravitational center around which the Milky Way organizes itself. And yet, for all this understanding, mysteries remain. How do the magnetic filaments form? Why does the circumnuclear disk remain stable? Why do some gas clouds collapse into stars while others stretch into filaments and disappear? What determines when the black hole awakens from slumber? These questions linger like faint echoes through the cosmic ecosystem, threads that connect our understanding to deeper, hidden structures. As we drift gently away from the galactic center, the glow of the core softens behind us. The stars spread out. The magnetic filaments fade into the distance. Yet the presence of Sagittarius A remains. Felt even thousands of light years away, a gravitational heartbeat that pulses through the galaxy. In the next chapter, we will explore how this heartbeat echoes across cosmic time, how Sagittarius A has shaped the past of the Milky Way, how it influences the present, and how it may determine the galaxy's far future. Part 10. The First Great Shift. When the galaxy was young. As we drift deeper into the story of the Milky Way, we must travel not only through space, but through time. The environment around Sagittarius A today is calm, comparatively gentle, balanced, and stable. But this was not always the case. To understand the true power of the black hole at our galaxy's center, we must look back billions of years to a period when the Milky Way was still forming, when chaos reigned, when stars were young, and when Sagittarius A reshaped the galaxy in its first great transformation. In the beginning, the Milky Way was not a graceful spiral. It was a turbulent cloud of gas and dark matter, an assembling structure drawn together by gravity. Small proto-galaxies merged, collided, and dissolved into the growing form of what would one day become our home. These early epochs were violent, luminous, and full of rapid change. And at the center of this chaos, a seed formed. Not a seed of life, but a seed of gravity. A black hole that may have begun as a collapsed massive star, or perhaps as a primordial object that existed before any stars formed. That seed grew. It consumed gas. It merged with other black holes drifting in the merging protogalaxies. It became heavier, denser, stronger. Over millions of years, it transformed into the supermassive black hole we now call Sagittarius A. As the galaxy continued to take shape, Sagittarius A6 became the anchor of its early structure. Gas clouds spiraled inward toward the forming disk. Stars coalesced from these clouds, forming the first generations of stars that illuminated the young Milky Way. But the early Milky Way was incredibly dense, filled with chaotic flows of gas, turbulent magnetic fields, and frequent collisions between clouds. These conditions allowed Sagittarius A to feed at a much higher rate than it does today. Streams of gas flowed into the black hole, forming a bright, hot accretion disk that blazed with enormous energy. Jets of plasma erupted from the poles of the black hole, shooting outward at nearly the speed of light. These jets punched through the young galaxy, injecting enormous amounts of energy into the surrounding medium. They carved cavities into the forming halo. They heated gas, preventing it from collapsing into stars too quickly. They redistributed heavy elements created by the first generations of supernovae. This period, known to astronomers as the quasar phase, was the first great shift in the Milky Way's evolution. During this phase, the black hole grew rapidly. The galaxy brightened dramatically. The jets may have extended tens of thousands of light years into space, shaping the early halo of the Milky Way in ways we still see today. We drift through this ancient memory as though observing from afar, watching the young galaxy flicker with brilliance. The central region glows with an intensity we cannot imagine today. Gas spirals inward in bright, luminous streams. The black hole flares repeatedly, unleashing bursts of radiation that ripple through the early disk. This early activity helped shape the Milky Way in fundamental ways. It regulated early star formation. It heated and redistributed gas. It influenced the angular momentum of the forming disk. It prevented the central region from collapsing into a single massive cluster. It created the foundations of the spiral structure we see today. But the most dramatic effect was yet to come. As billions of years passed, the galaxy slowly exited this quasar phase. The jets weakened. The accretion disk thinned. The flow of gas inward slowed. The Milky Way settled into a calmer, more mature state. Star formation stabilized. The spiral arms became more defined. Yet even after the most intense epoch ended, Sagittarius A continued to shape the galaxy through a series of smaller but still profound transformations. One such transformation occurred about 6 million years ago, a cosmic moment that whispers through the shadows of the present. During this time, a burst of star formation ignited near the galactic center. This event created some of the massive clusters we observe today, overflowing with hot, luminous stars. These stars blasted the surrounding region with intense radiation and powerful winds. As they aged, some exploded as supernovae, further enriching the central region with heavy elements. Many astronomers believe that this burst of star formation was triggered by a period of increased activity in Sagittarius A. As gas drifted inward and the black hole fed more intensely, it may have created shock waves in the circumnuclear disk, compressing gas and igniting the birth of new stars. This feedback loop is seen in other galaxies. Black hole activity sparks star formation, which then influences the future flow of gas toward the center. In this way, the black hole and the galaxy co-evolve, each shaping the other in an intricate dance lasting billions of years. As we drift through the memory of this later epoch, we witness a quieter but still powerful version of the quasar era. The black hole glows intensely, though not as brightly as before. The circumnuclear disk thickens. Gas collapses into clusters. The environment pulses with creation and destruction. Then slowly, the activity fades. The black hole quiets again. The starburst ends. The galaxy slips back into equilibrium. What remains are clues, subtle fingerprints etched into the structure of the Milky Way. The distribution of heavy elements in the central bulge. The alignment of magnetic filaments. The motion of ancient star clusters. The size and structure of the Fermi bubbles. And the quiet calm of Sagittarius A today. These clues reveal that the past of our galaxy is not static. It is dynamic, shaped by cycles of violence and rest, activity and silence. Sagittarius A is not a passive anchor. It is an architect that has rewritten the structure of the Milky Way many times. As we drift back into the present, the ancient turmoil fades. The chaos of the young galaxy dissolves into the quieter, gentler glow of the modern Milky Way. The black hole sleeps, as it has for centuries. But the echoes of its past transformations linger in every corner of the galaxy. And as we prepare for the next chapter of our journey, we begin to sense another, deeper question, one that has fascinated astronomers for decades. What comes next? In the next chapter, we will explore the second major turning point, the distant future of Sagittarius A, and how the black hole may reshape the Milky Way once more, in ways subtle and profound. Part 11. The second great shift. The future of the Milky Way's dark heart. As we return to the present era and drift once more around the quiet, sleeping form of Sagittarius A's, the question that guided the end of our last chapter begins to deepen. It echoes like a soft vibration through the cosmic dark. What will Sagittarius A become? The history of our galaxy shows that the black hole at its center is not fixed in its state. It shifts between silence and fury, between gentle influence and violent transformation. It has shaped the Milky Way at least twice before, in profound ways. And it will do so again. To understand the future of Sagittarius A, we must imagine the Milky Way not as it is now, but as it will be in millions, billions of years. Time, on these scales, behaves like a tide, slow, steady, quiet, and unstoppable. We begin with the near future, then the distant future, then the far future, beyond anything life on Earth will ever witness. And through all of it, Sagittarius A remains present, waiting, responding, shaping, and transforming the galaxy as it evolves. The near future, the next few million years. In this timescale, the environment around Sagittarius A will remain familiar. The black hole will continue to sleep lightly, producing occasional flares as small clumps of gas spiral inward. The circumnuclear disk will churn quietly. Massive stars in the surrounding clusters will continue to burn brightly, sending winds and radiation sweeping across the central region. But change is coming. One by one, the massive stars near Sagittarius A will reach the ends of their lives. Their supernova explosions will send shock waves through the gas. These shock waves will compress some regions of the disk, potentially igniting new episodes of star formation. They will also inject heavy elements into the environment, adding complexity to the chemical makeup of the central regions. As more supernovae occur, the dynamics near the black hole will shift. Some shock waves may push gas inward, others may clear gas away. But over millions of years, the outcome becomes clear. Fresh material will eventually reach Sagittarius A. We imagine this moment. A new inflow of gas begins. Thin streams spiral inward. The black hole brightens slightly, its quiet flares becoming more frequent, more intense. The sleeping giant stirs. This will not be a quasar-level awakening, not yet, but it will mark the beginning of a new feeding cycle, one that slowly transforms the surrounding region. The intermediate future, 50 to 500 million years. On this timescale, a more dramatic shift emerges. The Milky Way's spiral arms will continue to rotate, carrying giant molecular clouds into new positions. Some of these clouds, cold, dense, and massive, will drift inward toward the galactic center. Over tens of millions of years, gravitational interactions will shepherd them closer to the black hole. When one of these clouds crosses a critical threshold, tidal forces will disrupt it. The cloud will unravel into streams of gas. These streams will fall inward, forming a thick, bright accretion disk around Sagittarius A. For the first time in millions of years, the black hole will glow with sustained brilliance. The luminosity will increase by factors of hundreds, perhaps thousands. Jets may emerge once more, streaming outward into the halo. The central region will flare in X-rays and infrared light. From Earth, if humanity or its descendants are watching, a new star-like glow will appear at the center of the galaxy. This will mark the second Great Awakening. During this period, the black hole will regulate star formation in the surrounding region. Too much gas will collapse into stars. Too much energy from the black hole will blow the gas outward. The balance will oscillate, creation and destruction cycling through the cosmic ecosystem. This awakening may last 1 million years, or 10, or 50. Then, slowly, it will fade again as the available gas is consumed or blown outward. The galaxy's heart will dim, the giant will sleep again, and the cycle will continue. The far future, hundreds of millions to billions of years. Now we drift forward to a future more distant than any human imagination naturally reaches. A future when the sun itself will have burned out, when Earth will no longer exist in any recognizable form. By this time, the Milky Way will have undergone another transformation, one far more dramatic than any internal cycling of gas. The Andromeda galaxy will have approached and collided and merged with the Milky Way. This event, scheduled to occur roughly 4 to 5 billion years from now, will reshape everything. The collision will pull stars into new orbits. It will stretch the spiral arms into bridges and tails. It will fling entire clusters across space. Clouds of gas will collide and compress, triggering massive bursts of star formation. The two central black holes, Sagittarius A and the black hole at the center of Andromeda, will spiral toward each other through gravitational friction. Eventually, after hundreds of millions of years, they will merge. This merger will create a black hole tens of millions of times more massive than Sagittarius A is today. The energy released in this moment will be staggering. Gravitational waves will ripple across the universe. The newly formed black hole will feed intensely on the surrounding gas, entering a new quasar phase. It will blaze with brilliance that outshines the entire combined galaxy. And this phase will shape the new galaxy, sometimes called Milky, for billions of years. The black hole will regulate gas flow. It will drive the formation of new structures. It will sculpt the final evolutionary stages of the merged galaxy. In this far future, Sagittarius A will no longer exist in its current form. It will have merged, grown, transformed. Its identity will be absorbed into a far larger cosmic being, a new central black hole at the heart of a new galaxy. Yet even then, its influence will endure. Every star, every structure, every orbit, every cloud will carry echoes of Sagittarius A, the dark heart that once anchored the Milky Way. The final future, trillions of years ahead, in the most distant future imaginable. Long after all stars have faded, long after the galaxies have gone dark, Only black holes will remain, and even they will slowly evaporate through Hawking radiation. Sagittarius A, or whatever it becomes after its merger, will one day fade too. Not in our lifetime, not in the lifetime of the universe as we know it, but eventually. A final whisper, a final release of energy, a final fade into the dark. The story of Sagittarius A, then, is not just the story of the past or the present. It is the story of the entire life cycle of the galaxy. The story of creation, transformation, collapse, awakening, and silence. As we drift back to the present moment in our meditative journey, we carry with us the knowledge that the quiet giant at the center of the Milky Way is not simply a passive object. It is a cosmic force woven into every chapter of the galaxy's story, from its chaotic birth to its distant, unimaginable future. In the next part of our journey, we turn inward once more, toward the mysteries of space and time themselves, and toward the philosophical questions that Sagittarius A inspires. Part 12, the second turning point. When reality bends. As we continue drifting deeper into the conceptual heart of our journey, we reach one of the most thought-provoking chapters of the entire story, not just of Sagittarius A, not just of the Milky Way, but of the nature of reality itself. If the first great turning point in our cosmic tale was the formation and early awakening of the black hole, the second turning point is something far more abstract, far more philosophical, and yet grounded in physics so precise it reshapes our understanding of existence. To explore this turning point, we must look not at the past or the future, but at the edges of knowledge, at the strange frontier where gravity and quantum mechanics collide. This is the frontier shaped by Sagittarius A, where time slows, space curves, and the rules of the universe grow flexible. Here, at this frontier, the black hole becomes more than a physical object. It becomes a question about the limits of space-time, a question about the nature of information, a question about the fate of reality inside the most extreme environments the universe can produce. We drift toward the event horizon again, not physically, but in thought. We return to the boundary of no return, that silent sphere beyond which nothing escapes. Inside it lies the singularity, a region where the known laws of physics fail. Outside it lies a universe governed by equations we understand. And on the boundary between them sits one of the greatest puzzles in modern science. What happens to information inside a black hole? This is the second turning point, the moment when Sagittarius A forces us to confront the limits of what we know. The information paradox begins with a simple assumption. If something falls into a black hole, it should be lost forever. But the laws of quantum mechanics insist that information cannot be destroyed. Even when matter is transformed, the information describing its state must persist. General relativity, on the other hand, predicts that information swallowed by a black hole disappears behind the event horizon, and ultimately into the singularity. These two ideas cannot both be true. And so, Sagittarius A, quietly rotating at the center of our galaxy, becomes the focal point of the greatest intellectual conflict in modern physics. Its existence forces the universe to reveal one of its deepest secrets. How do gravity and quantum mechanics reconcile? We drift through this conceptual space, sensing the tension between theories. We feel the soft pull of gravity and the subtle, granular texture of quantum reality. And then we explore the possibilities, each one an attempt to solve the paradox. One possibility is that information is smeared across the event horizon in a thin layer known as the holographic surface, an idea rooted in the holographic principle. In this view, The three-dimensional world inside the black hole is encoded on its two-dimensional horizon like a cosmic data screen. Another possibility is the existence of soft hair, subtle quantum imprints on the black hole's surface that store the missing information. Yet another proposes that the event horizon is not a smooth surface, but a firewall, a searing boundary that burns away anything attempting to cross it. This would resolve the paradox, but destroy the elegant predictions of general relativity. We drift among these theories, feeling their shapes, their implications. Each one bends reality in a different direction. But the strangest possibility is that the interior of the black hole is connected to another region of space-time. That black holes may be bridges, wormholes, shortcuts between distant points in the universe. In this view, information is not lost. It is transferred. It is preserved not here, but elsewhere. Sagittarius A, then, may be more than a gravitational anchor. It may be a doorway. Not a doorway we can pass through. Not a doorway that leads to science fiction, but a doorway in the fabric of reality itself. A region where space-time loops and folds, where the architecture of the universe becomes surreal. We do not cross it. We only imagine the shape of the mystery. As we drift farther through the conceptual landscape, we encounter another layer of the turning point, the nature of time near the black hole. In everyday life, time is steady, predictable, linear, but near Sagittarius A, time becomes elastic. It stretches, it bends, it slows to a crawl. The deeper an object descends toward the event horizon, the slower its time passes relative to the outside world. To the distant observer, the falling object freezes. To the object itself, time flows normally. This is not metaphor. This is reality. It means that the black hole is a time machine, not in the fictional sense of traveling to the past or future, but in the physical sense that it changes the rate at which time flows. It reveals that time is not absolute. It is shaped by gravity. This realization is the second turning point, not a moment in history, but a shift in understanding. Sagittarius A forces us to reconsider time itself. It forces us to reconsider space. It forces us to reconsider the meaning of inside, outside, past, future, information, reality. And this conceptual turning point is not only scientific, it is philosophical. When we reflect on the nature of a black hole, we encounter questions about the meaning of existence. If information cannot be destroyed, what does that imply about the continuity of identity? If space-time can bend, what does that imply about the boundaries of the self? If time can stretch, what does that imply about the nature of consciousness? Sagittarius A becomes a mirror, a dark mirror, and through it, we glimpse the deeper structure of reality. We reflect on these ideas as we drift in the quiet space near the horizon. The Milky Way glows behind us in a soft, luminous arc. The stars appear calm. The galaxy rotates gently. And yet, at its center, the laws of the universe twist into something almost unrecognizable. The second turning point is this realization. The universe is stranger than we think, and black holes are the keys to unlocking its deepest truths. As we prepare for the final chapter, we carry with us not just awe, but humility. The journey toward Sagittarius A has shown us the power of gravity, the rhythm of cosmic cycles, the life cycles of stars and galaxies. But Part 12 reveals something even more profound. The black hole is not only the heart of the galaxy, it is the frontier of reality. In the final chapter, we will explore the echo, what Sagittarius A means not for astronomy, but for us, our existence, our place in the cosmos, and the quiet understanding that emerges when we look into the dark heart of the Milky Way. Part 13. The Echo. What Sagittarius A teaches us about ourselves. As our long, quiet journey through the center of the Milky Way approaches its end, we drift one final time around the dark, silent presence of Sagittarius A. The black hole no longer feels distant or abstract. It feels like a companion, one that has guided us through the history of our galaxy, the extremes of physics, and the boundaries of human understanding. Now, in the final chapter, we turn away from facts and theories. We turn toward meaning, because Sagittarius A is not only an object of study. It is a reflection, a cosmic mirror, revealing truths about the universe and quietly about ourselves. We begin with a simple observation. The center of the Milky Way is quiet, calm, balanced, held together by a force we cannot see. And yet that invisible force determines everything we are. Our sun orbits Sagittarius A. Our solar system's stability depends on the structure of the galaxy. Earth exists because the Milky Way formed the way it did. Life emerged because of conditions shaped by cosmic cycles, gravitational patterns, and ancient transformations that began long before our planet was born. Sagittarius A is the silent guardian of our home, a gravitational anchor that holds the galaxy together, allowing life to flourish in one of its distant arms. And from this realization emerges the first echo. We are shaped by forces we cannot see. Just as stars respond to gravity, we respond to invisible forces: memory, emotion, history, culture, time. They bend the paths of our lives in the way gravity bends starlight. They shape our orbits. They define our motion. The second echo emerges as we recall how the black hole sleeps for millions of years, only awakening during rare and powerful events. Great change does not happen continuously. It happens in cycles. Just like Sagittarius A, we have periods of quiet, periods where nothing seems to change. But deep beneath the surface, pressure builds. The future gathers itself. Small shifts accumulate until, suddenly, something awakens within us. A transformation begins. A new chapter forms. The universe evolves slowly. Galaxies evolve slowly. We evolve slowly too. And that is not a flaw. It is a rhythm. The third echo arises from the strange truth we uncovered in the last chapter, about the nature of time near a black hole. Time is not absolute. Perspective shapes experience. Near Sagittarius A's, time slows. Far from it, time flows faster. Two observers can witness the same event differently, not because reality changes, but because their perspective changes. Our lives work the same way. Moments feel long or short depending on how we experience them. A year may stretch endlessly for one person and vanish instantly for another. Perspective defines our reality far more than we realize. The fourth echo is deeper still. It comes from the information paradox, from the idea that even in the darkest places, nothing is truly lost. Everything leaves an imprint. Everything echoes. Everything continues in some form. When something falls into a black hole, its information is not erased. It is transformed, woven into the fabric of the horizon, encoded in ways we may not yet fully understand. And so it is with the events of our lives. Nothing is truly lost. Not the lessons, not the memories, not the quiet transformations that shape us. We carry them all, subtly, invisibly, beneath the surface of our consciousness. The fifth echo emerges as we drift farther from the event horizon, gazing back at the swirling heart of the galaxy. The greatest power can exist in silence. Sagittarius A is not bright. It does not roar. It does not shine. It influences the galaxy not through violence, but through presence. Its gravity organizes billions of stars, yet it says nothing. Its mass shapes the structure of the Milky Way, yet it is invisible. In a world full of noise, the black hole teaches us the quiet strength of stillness, the power of gravity without motion, the steadiness of a center that holds, the value of being instead of performing. The sixth echo is one of humility. We are small, but not insignificant. Floating here in our imagined journey, we see the Milky Way stretched across the dark, a vast island of stars. Our planet is a speck, our lives a spark. And yet, we belong to this cosmic story. We are made of atoms forged in ancient stars. We are shaped by the galaxy's architecture. We are the universe looking back at itself. The final echo comes at the end of our journey. It is not a fact, not a concept, but a feeling. The cosmos is deeply, profoundly connected. Sagittarius A is connected to the galaxy. The galaxy is connected to us. We are connected to each other. The forces that shape stars also shape minds. The rhythms that govern orbits also govern experience. The stillness at the heart of the Milky Way echoes in the stillness we carry within. We drift one last time around the black hole, feeling not fear, but tranquility. Its darkness is not emptiness, it is depth. Its silence is not absence, it is presence. Its gravity is not destruction, it is connection. And as our journey ends, the final image remains. A quiet heart at the center of a galaxy. A rhythm too slow to hear, a presence too soft to see, a force too vast to comprehend. And yet, a reminder that somewhere, in the vast silence of the universe, even the darkest places hold meaning. Even the quietest forces shape entire worlds. Even the invisible can be the most important. This is the echo of Sagittarius A, the echo of the Milky Way, the echo of the cosmos, and the echo we carry within ourselves. Our journey ends here, but the galaxy continues turning around its silent, ancient heart. And so, in our own ways, do we.